Okay, this is the presentation on turning. It's the thing that you do when you use a lathe. And it's a chip removal process, which means it's machining. And we're looking at a single point cutter where the material spins around and the device that cuts it is held steady. The video at the bottom of this page, you may want to take a break right now and watch that, because that video is fairly short, 2 or 3 minutes, shows a lot, it gives a lot of information that I'm going to try to describe, and I normally show that video to the entire class, and it's very well worth taking a break right now, watching it, and then coming back to this presentation. We're going to learn about facing and regular turning. Now, the machine that does all this is called a lathe, and there's engine, turret, wood lathes. The most common lathe, particularly for manual machining, is engine lathe. The turret lathe will usually have would be more of a CNC machine, which we'll get into in a whole nother unit. And I will talk just briefly about wood lathes. Now, this is an old one, and you think, oh, it's got to be different than today's modern ones, but you know what? Over on the right you have the tailstock, on the left you have the headstock, you have the thing in the middle called the apron, and that little thing standing up in the middle is a tool rest. Put a long piece of material through there and it can hold it steady if it's particularly long. And here's a modern one. Wow! On the left is the headstock, on the right is the tailstock, there's an apron in the middle, and here they have a tool rest there kind of in the middle. It's a circular thing with, looks like some knob coming down. Usually you take those off, but and particularly if you're doing small pieces of work, it's really only useful if you're turning something that's 3 or 4 feet long. Now, all lathes have their controls on the left in terms of speeds, feeds, how you can flip things around. Then there's some levers on the apron, and then there are wheels. The wheels run the carry the tool into in, out, up, down, well, not up, but left and right, and in and out. One of the videos, one of the machine shop videos, has a very good explanation of what the z-axis is and what the y-axis is. And here's the names of all the stuff that goes onto it. You can pause here and memorize all these names if you want to. Notice that the tool post is sitting on what's called a compound rest. You'll see that on the videos. And here's another picture of it. And I thought I had deleted this picture, but I hadn't. Okay, well, what holds the material? The most common thing to hold it is a 3-jaw chuck. And you can see here, and you see in the videos, the chuck clamps down on the material. You turn one wheel and all 3 work together. There's also a 4-jaw chuck shown at the bottom. The 4-jaw chuck has each jaw runs independently. And what the advantage of the 4-jaw chuck is that you could actually take a square or rectangular piece of material, mount it up there, and then use the lathe to create a hole in that piece. It could be dead center, it could be off center, but you don't have to, you can do square material on a lathe. Now, the part that does the cutting, sometimes it's just called a tool, as I said, tool holder, or whatever your tool is. There's a couple of different kinds. High-speed steel is still around. It was it's being replaced in a way by um, ceramic inserts. I'll show you examples of those in a second. Um, in the video, the Machine Shop Secrets video, it shows a lot about different angles of cut and being able to shape things around. He's actually taking a bar of high-speed steel, and he talks about going over to the grinder. But yes, he is actually grinding a particular angle on the front end of that piece of high-speed steel that gets put into a tool holder. And those angles and the different shapes of these cutting points can be done for different operations. The inserts are basically have one shape, but for the most part, that's the shape that you want to work. I'll show you the different types. You've got side tools. It could be left pointing, right pointing. These are ones that would have inserts in them. You have a cutoff tool, which is also called a parting tool. And when you saw my homemade video where I was making the file handle, I used the parting tool, the cutoff tool, to cut the piece off at the end, and you'll see that in the videos where it's used. The boring bar, it looks like just a regular side tool turned sideways, and in a way it is. It is for going into the inside of holes. You drill a big hole, and then you can put the boring bar in the tailstock and use it to go in and cut on the inside of cut an inside diameter. And from the one at the top may look a little weird, but that is actually a fairly common type of shape that is made with a solid bar of stock. It started with that big base, which they're calling it the axis and the base and the shank. And that was just a bar of material that the cutting surfaces are ground away. And you've got the major cutting edge and minor cutting edges, and you've got any one of those is sharp enough to do the job. The two at the bottom are ones with inserts. Nobody much brazes one in anymore, but gives you an idea of putting the insert in and then locking it in place with some sort of clamp. In that case, the area where it says the insert, that would be one of the cutting surfaces. And to get real life pictures, here's what they look like. Now, these are the holders. If you look at A, B, or C, on the left, you see that the square high-speed steel piece is sticking out and is locked in with the what's clearly a bolt at the top, and then that the rest of that tool holder holds it in place. This is what you see me using on the videos, of the homemade videos. On the right, you've got the same thing that would go into the tool rest, but it would have these inserts in them. Now, what's happening when we're doing this? The cutting tool, and you really can't see much difference between A, B, C, and D, and E, but the cutting tool is the solid piece going into the softer piece that has a grid on it, and as it forces itself in, it's harder and cutting away part of the metal, which is the part with the grid on it, and that's basically what's happening. A harder piece of metal is displacing some other pieces of material. Here's one other way to look at it. The tool, and you want to think about the shear zone, and one of the things that's happening, there's a lot of stuff dealing with angles. I want you just to be aware of the fact that you've got the angle at which the tool is coming in, the angle at which it is cutting, and what's being done, how it's being done, all impact the quality of the cut. And that shear zone is where it gets really hot. Now, we're looking at um, continuous and discontinuous chips. The preferred way to do it is on the right, where it's continuous. You can begin to see the grain structure in those pieces of metal that are being cut. And sometimes you just aren't going to get a continuous chip because the material may be particularly hard, it may be particularly um, prone to breaking up because of the grain pattern on the inside. But most aluminums will give you a continuous chip if you're cutting at the right speeds and depths and stuff, which I'll be talking about in just a second. And you want to try to go for a continuous chip. Discontinuous chips maybe because you're going too slow, maybe because you're doing too, it could be a variety of reasons. And I mentioned something here about where you would put the cutting fluid if you were cutting. There's a little video on cutting fluid. We don't do cutting fluids in this class because it's kind of the next step or step up, and it's not exactly advanced, but it just becomes something that we don't need to really worry about. But you would put the cutting fluid in that space where the backside of the chip is being made, because that's the part that's hottest, because that is where the metal is being ripped apart. And there's basically two types of cuts that you're doing. The outside surface, which is also called straight turning, and it's identified on that video from slide 1. Unless they've changed it, they actually bring up some of these words. If you're working on the end of a piece, it's called facing. And so they're the two different types. The outside part, or turning, or facing if it's the perpendicular to the part. There's also parting, which I'll talk about in a minute. And you can have several variations. Left hand going, right hand in the middle, round. You don't have to memorize all these. But you can also do what's called threading on a lathe. Now, it's not a particular, it's very advanced, and B, it's not done much anymore. External threads like this are going to be cut with a die, which I think was explained in one of the videos in drilling, or no, threading, tapping. One of my former students who went on to become a production manager at a local manufacturing company, in charge of the machine, and the company had a machine shop, and he was in charge of that. And he said if he caught one of his machinists manually cutting threads, either it was going to be on their own time or they would be fired, because the only time you do those on regular manually operated lathes is because you want to learn a little bit, or because you are having to make a part for some sort of repair or otherwise. It's very slow and very painstaking to do that, and you just don't see it much out there in the world. You also have the cutoff. You've seen that, and there's examples of boring. I'll be talking about boring a little bit later. And here is the idea of what it's going. Keep in mind that the big gray parts are spinning around, and the cutting parts are staying rigid. You can do a lot of different kinds of cuts. side tools, you can facing, you can bore holes through, you can drill holes through. It's harder to do some of the other stuff with thin plates or thin slots. You may have to have special tools, but you can do some others. And there are things you just cannot do on a lathe. So if you design it in, you better have a 3D printer. And 3D printers in production don't really go together because 3D printing can be slow. Here I'm going to introduce the idea of speeds and feeds. I'm going to talk about it again when I talk about milling and try to go through how to calculate it. Not going to calculate it here. But the three key variables of the cut are the speed that the material is being rotated, the depth of cut, and the feed rate or the sending speed, how fast it's being sent down the end. And of course the material is a variable, but that's accounted for differently. So those are the three variables. Now 100 thousandths is a pretty good, you might want to do 50 thousandths just to first time out, but you can go 100 thousandths, and whatever your roughing depth of cut is, you're going to want to have your finishing depth of cut approximately half that. And so you got to calculate that. How fast you go down the side, that sending speed or feed rate can matter, and the rotational speed is something that you calculate. We're going to learn how to calculate that in the milling presentation, which will be the next one after this. Now, what can happen if you turn the wheel that moves the cutting tool too fast? You're going to get grooves because this is a single point cutting, and so look a little bit like you're putting screw threads on it. So you want to go slow. You want to slow it down, and then you will get a nice smooth cut. If you put the material in the chuck improperly, you will not get a good product at the end. It's easier to do than you think. You'll notice here that they had a piece, and they're flipping it around and then got it out of whack, and it's messed it up. It's hard for you to conceive of this, but if your part is way out away from the chuck, and maybe it's thin or whatever, you can actually end up pushing it out of the way rather than cutting it, or cutting a little bit but also pushing it out of the way, and you can end up with a part that does actually look like this, where after you've machined it, by gosh, the end is bigger than the part that was close to the chuck. Well, to fix that, what you would do is you would put your piece in a tailstock, or put your tailstock, drill a hole, mount the material so that it won't rattle. You'll see that I did that in my homemade videos about turning. Very definitely normal process. And this is just show you, there's a video on coolant. I just talk about coolant in this class and the necessity for it. And the harder your cutting tools are, the ceramics or the carbides, they can handle higher speeds at higher temperatures, not higher speeds, but temperatures that get hotter than you can with the high-speed steels. And so they may be able to make some cuts without coolant, but the high-speed steels would need some coolant. Okay, very, very briefly, wood turning. It's more of a hobby. It's a craft thing, but it does do the same sort of thing. You handhold the tools, and they have funky names like gouge, and they have a parting tool and skews. And you move longitudinally by hand. You can also do facing, but you have to mount the wood in a faceplate. There are two videos on this, one showing regular turning and one showing faceplate turning. And here's the parts of a wood lathe. You have your headstock and your tailstock. You don't have the thing with the steady rest or material rest. Here the tool rest could slide up and down and you would put your tool on it. Watch the videos if you want to know how to do it, and when things are back to normal and you can come into campus, I'll be more than willing to show you how to do wood turning. And those are the different tools that you use. And the mallet, the round mallet, but you're just beating the parts together to hold them in. Okay, that's turning.